So you call it Z, I'm used to calling it Z. Doesn't matter how you call it, but it is a score. So what is it? We simply take an observation from the data. You subtract the mean. And divide by standard deviation.
The sample or population?
Sample. That's a good point. And I'd like sample. As far as this class is concerned, we are going to use sample standard deviation for the most part, unless otherwise specified. So Z-scores typically play a significant role when it comes to normal distributions. By all means, people tend to use, or people will use Z-scores if the data has split skew. So this number that we found is a Z-score. So an observation gets converted to a Z-score. There are multiple reasons as to why we use Z-scores. This is what we call standardizing. So just like the coefficient of variation, if you have two different groups, say males and females, and they are in some sort of a race, and a male completes in 7 minutes, female completes in 6 minutes. Naturally, you may say, well, females did poorly than males, or females did better than males because they were faster in 6 minutes. But if you make it relative to their own group, they might be at the same level. Do you see what I'm saying? If you take the time relative to your own group, females, males relative to your own group, then perhaps you're at the same level. That's the purpose of a Z-score. Second purpose, so in other words, it helps rank things from different samples properly. Another advantage of a Z-score is if the data is normally distributed. On the Z-score axis, so if an observation lies above 3, the Z-score, not the observation itself, the Z-score of an observation, if it lies above 3 or below -3, then that particular observation is an outlier. It is very, very unusual. If it is above 2, -2, it's just unusual. Good. The key thing to note is we're going to compare the Z-scores, not the observations themselves. We have seen this before, the exact type of vocabulary using unusual, very unusual. Wow. I'll give you a hint. It has an empire.
What about you?
How, like,
I thought you were about to answer, I was excited.
Oh, I'm sorry, no.
Go ahead,
How do you define a Z-score? Like, what,
I'm going to show you.
um,
So this is the formula, but I'm going to show you an example on how to find it. We have seen this before, when we said unusual, very unusual, not unusual.
the empirical rule?
Thank you. The empirical rule of normal distribution. So if you remember, the 95%, 68%, 99.7%, the numbers that you had at the 99.7% mark, 3 standard deviations away. That 3 is this 3. So the number of standard deviations is simply the Z-score. 2 standard deviations away, you said 95% would lie in the middle. That 2 that you solved in empirical rule is the same here. Which is why when I started Z-scores, I said Z-scores are great if the data is normally distributed. Does that make sense? Yeah. Okay. Well, we'll do a simple one on computing. Okay, so what we have is lifespans of fruit flies. The problem states a specific species of fruit flies. Right. They have a bell-shaped distribution, in other words, normally distributed, check one of the conditions, with a mean of 33 days. In other words, X bar is given to us. All right, look at here. The standard deviation is 4 days. Good. Now, part A, the lifespans of 3 randomly selected fruit flies are 34, 30, and 42. Find the Z-score that corresponds to each lifespan and determine whether any of these are unusual. I'm going to do the first one. You can try the other 2. Or Annabelle, right? This is the process.
Yes.
I'm going to do the first one. The observation is X, so vertical, minus the mean, 33, divided by the standard deviation, 4. I get positive 1/4. Yes? Yes. Let's quickly find the other 2.
Did you convert them into decimals? Would you convert them into decimals at all?
We can't.
So that's usual. Do we just write usual?
One step at a time,
All right.
Alex. So the next one, what is the Z-score?
-3/4.
Negative 3/4. Negative 0.75. 42 minus 33/4.
9/4.
9/4, 2.25.
Yeah.
Good. All of these observations have Z-scores under 3 or above -3. Do you agree?
Yes.
So none of them fall. it a fire alarm?
I think so.
It's always.
I'm
It's
so
cool.
sorry.
It's a fire alarm.
I was ready to run outside. I hate
You guys are so excited.
I was ready to I was like, all right, I'm gonna.
So, if it's less than -3, the observation is an outlier. If it is greater than 3, the observation is an outlier.
Oh.
None of them satisfy that, so none of these observations are outliers. Yes.
We said beforehand, it's less or something.
If it is less than 3, the z-scores,
Okay.
unusual or outlier. If the z-score is greater than 3,
Wasn't it very unusual?
Very.
very happy.
There we go.
She would be at.
So 34, 30, and 42, all lifespans fall here.
Is it always 3? Or is it dependent?
It's always 3 and -3.
Why?
Patience, can't be explained.
2.25, unusual. So in our chart, it said that 2 was unusual. Would that mean that 2.25 is considered the unusual out of those?
Yeah.
Yeah, okay.
The book splits it into 2 types, unusual, very unusual.
Okay.
If it is unusual, this would be unusual because it's above.
I just, where was it? Yeah, because that's which lifespans are unusual.
Oh, is it
Very
asking for unusual?
Yeah.
Then this one, because it's above 2.
Okay, that's what I thought.
Very unusual, above 3. The book differentiates this, we saw that, but empirical rule. I want to show the relationship between this and the empirical rule. So I'll let you try this at home. I'm going to take the same problem and connect it to empirical rule. Yes.
So for outliers, would they have to be in the very unusual to be considered an outlier?
Yes.
Okay.
Okay. The mean is 33. And we know something about the empirical rule.
Yes.
Within one standard deviation, what percent would we have? 68%. So one standard deviation would mean 33 plus 4. 33 minus 4. Good. Within 2, yes.
With 33 minus 40, 29.
Oh, I'm sorry.
Yeah.
29, bad man. 29. Thank you. 33, 2 standard deviations, so 37 plus 4, which would be 41. Here we subtract 29 minus 4, 25. 2 standard deviations from the mean, 2 times 4, 8. 33 minus 8, 25. What are the numbers? We got 3 standard deviations.
We have
95.
95%.
No, these 2 numbers.
Oh, that was right.
21 and 45.
45. And over here,
21.
21. So between these two values, we would have 95%. Between those two values, we'll have 99.7%. With me?
Yes.
I'm going to pick one from here, then I'm going to ask you to guess for this. What percentile would the number 37 be? That's right in the middle, correct? Median. So what percent lies below the median? 50. 68 lies here. It is symmetric.
So we're 84.
Okay. So 50% up to 33 plus 34%. In total, we would have 84% below 37. Do you agree? Which would make 37 be 84. Good. What percent lies below 25?
5.
Huh?
5.
Alex says 5, and I'm going to say he's wrong.
2.5.
Who said 2.5?
Uh,
Why? What's your name? Aiden. Why? Half of 5 is 2.5. In the middle, you have 95%. So outside, you have 5%, and it's symmetric. So 2.5 there, 2.5 here. So 25 would be P 2.5. That's probably what the book would want, approximately the third percentile. That said, I want you to guess the percentile for 34. I'll give you options. Could it be P50? No. Could it be P40?
No.
No. Could it be P59?
Yes.
Yeah.
Possibly. Why? 34 lies above the 50th percentile. Does that make sense?
Yeah.
Okay. Guess for 30. Could it be P47? 47 is close to that point. Oh, sorry. Is that 30? Yeah. 30 is close to 29. It's right over here. Yes? What percent would lie below that number?
Below 33, 50.
So 50% below 33, accounted for 34%. What percent lies here? 16. So that would be P16. So whatever 30 is, it has to be close to P16. Lastly, 42. Where does 42 lie? Somewhere over here?
Yeah.
Yes? I'll say 42 is right there. So we know below 41, we have 95%. 2.5% below that. Could 42 be P87? No, why not? Logic, explain the logic to me, Alex. Everyone's looking at you.
I don't know.
Wait, below it.
Because it has 95 already plus 2.5.
Exactly. So 41 is at P95, yes? And you're adding P97.5, because below 41, you have 95% and 2.5%, which would make this P97.5 percentile, or approximated 98th percentile, correct? So 42 cannot be the 80th percentile, probably is 99th percentile. Does that make sense? repeat the same process for this problem. I will do that problem on Tuesday. So I want you to try it before you come to class. I will do that problem and we will wrap up 2.5 and start chapter 4.